This isn't just about spinning parts, it's the birth of pure mechanical power, built to last for decades. Welcome to Winds of Thought. Today, we're going deep inside the heart of modern industry to witness the creation of an industrial electric motor. From raw metal to a powerhouse ready for the most demanding jobs, this is a journey of incredible precision. Our focus is a leading manufacturer with over half a century of heritage. This facility produces the muscles for our world, motors that drive pumps in water systems, fans in power plants, and machinery on factory floors. Their catalog spans thousands of specifications, from ultra-efficient designs to motors built for explosive environments. How does a simple concept become such a reliable, complex machine? Let's find out. It all starts not with a bang, but with a precise stamp. The lifeblood of any motor is its core, crafted from special silicon steel sheets. This material is chosen for its magnetic properties. It's what allows the motor to convert electricity into motion efficiently. In the stamping area, computer-controlled machines punch out delicate laminations with intricate shapes. Each thin piece features slots and holes that will later house copper wires and allow for cooling. Stacked together, these laminations form the stator and rotor cores. But here's the critical part: they must be perfectly aligned. Any error here creates vibration and waste heat later. So, how do they lock hundreds of fragile pieces into a single, solid unit? With the core ready, we move to where the motor gets its pulse. Technicians carefully line the stator slots with insulating paper. This barrier is crucial. It prevents the high-voltage electricity from short-circuiting. Think of it as the motor's nervous system insulation. Next comes the winding. This is where art meets automation. Preformed coils of copper wire are inserted into the stator with meticulous care. A machine helps place each turn, ensuring the winding is tight, uniform, and undamaged. This copper maze is what will create the electromagnetic field. Once set, the coils are bound and shaped. But a loose coil is a failing coil. So, what's the secret to making them last 30 years in a harsh environment? The answer comes next. The stator undergoes a transformative bath called vacuum pressure impregnation. It's placed in a sealed tank, all air is sucked out, and then insulating varnish is forced into every microscopic gap. After baking, the windings are locked in place, immune to moisture, vibration, and heat. This step turns a fragile assembly into an unbreakable heart. Meanwhile, the rotor is born from molten aluminum, die-cast under immense pressure. Once cooled, it's dynamically balanced. Even a gram of imbalance at thousands of RPMs would be catastrophic. Technicians drill tiny holes until it spins in perfect harmony. Now, the pieces come together. The fortified stator is pressed into the robust motor housing. The balanced rotor is carefully slipped inside its gap, a hair's breadth away from the stator walls. Precision bearings are fitted onto the shaft. These will carry the load for years. End covers, cooling fans, and a terminal box are installed. Every bolt is torqued to an exact specification. This isn't just assembly, it's symphonic integration. A motor isn't finished until it proves itself. Each unit enters a rigorous testing bay. It's run at full speed with no load, checking for abnormal noise or vibration. Its insulation is stressed with high voltage to ensure safety. It's analyzed for efficiency. One question remains: can it handle the real world? Selected motors are put under simulated load, pushing them to their design limits. Only the ones that pass every trial earn their final coat of protective paint and are cleared for shipment.